Hello, beautiful people, and welcome. In today's video, we are going through part 2 of your Chapter 3, Are You Ready packet. As always, I am human, so if I make a mistake, please let me know where the mistake occurs so that way I may learn from it. Let's go ahead and get started with solving equations. Now, these right here, step number 1 is you're always going to try to factor. If you can factor, then you do not need to proceed with the rational root theorem. However, if factoring is not possible, then yes, you have to do the rational root theorem to check for rational roots. All right, let's go ahead and get going. For this one here, I see step number 1. We're going to see 4 terms. We're going to try to factor out a GCF. I have a 2, a 7, and a 2. So 2 and 7, they don't get along, so we don't have a numerical GCF. I have an X, no X. So that means I do not have a GCF. Step number 2, or I guess still step number 1, we're going to still consider factoring possible by grouping since I have 4 terms. So I'm going to group 2x cubed minus 7x squared together, and I'm going to group a positive 7x minus 2. Pulling out GCFs, I can remove an x squared, leaving behind a 2x minus 7. Here, 2 and 7, they don't get along, so the only GCF I can pull out is 1, leaving behind 7x minus 2. Now, the check here, if we can factor, is the leftovers. If yes, I can factor, then the leftovers must match. So the leftovers I'm talking about is here and here. Since they do not match, that means no, we cannot factor. Let's see if I can make this a little less blurry. Okay. That means we're moving on to step number 2, which is our rational root theorem. Silly snake, we're going to list out all possible roots. That means I'm taking my constant and writing it on top of my leading coefficient. So I want to color code this for you so you know which one goes on top. So this 2 right here goes on top. And then this 2 here, this leading coefficient, goes on the bottom. Now you're going to be listing out their factors. So where factors are things that multiply to that number. So for example, I have plus or minus 1 and plus or minus 2 because 1 times 2 is 2, 2 times 1 is 2. And again here, 1 and 2. Now, every single numerator has to go in every single denominator. So count how many denominators you have. You have 2 denominators. So that means 1 is going to be written twice. And each one gets a denominator of 1 and 2. Then this 2 right here gets written twice. And then each one gets a denominator of 1 and 2. You need to simplify your fractions if you can, always keeping the 1 plus or minus. So we get 2 here, and then again here we can simplify so we don't need a repeat of 1. So our possible roots, I'm going to go ahead and put that in a thinking bubble. That's going to be plus or minus 1, plus or minus 1/2, and then plus or minus 2. Step number 3, we're going to open up your equation. Now, if you had a GCF, this is where you're going to use the leftovers, not the original. Oops. You need to open up for X. And now we're going to be testing on our calculator what can or cannot equal to 0. So I'm going to always start, me personally, I usually start with a -1, so I can go back and delete it. So we're going to open up for -1, square it, plus 7, open, -1, close it, -2. So this one does not give me a 0. So we're going to go back and delete the negative on 1. And I do get 0. So that means 1 is a rational root. So for step number 4, I'm going to write x equals 1. I'm going to then proceed to do synthetic division by copying that root of 1 here. And then these are our coefficients. Make sure that if you have anything missing that we write it in. So for example, if you have a term like x squared missing, then you'd write 0 here, but we don't. So we don't have any zeros. So 3, 2, 1, 0, 2, negative 7, positive 7, negative 2. Bring down the first coefficient, multiply on the outside, add on the inside. So 2 times 1 is 2. Add, we got 5, negative, negative 5, positive 2. We get 2, 0. Now this again must be 0. If it is not 0, that means you did something wrong, okay? So either the mistake could be in your synthetic division or your mistake could be in step number 3 where you identified a root that wasn't your root. Okay, working backwards, here's our remainder. Here's our exponent of 0, exponent of 1, exponent of 2. Step number 5, you're going to be writing out your quotient, which is the answer to your division that you just did. So we have 2x squared minus 5x plus 2. And then again, you're going to try to factor. This is step number 6. So sometimes, yes, you can factor. Sometimes, no, you can't factor. If you cannot factor, then you have to continue again with another round of the rational root theorem. So this is now our round 2. I'm going to draw an arrow here just for space. I got 2x squared minus 5x plus 2. I'm noticing I have a trinomial leading coefficient of not 1, so I'm going to use my rainbow method, multiplying the leading coefficient by the constant. Here I see that I can get two factors of negative 4 and negative 1 to multiply to a positive 4 and add up to a negative 5. Again, remember this right here is temporary. It doesn't exist, so we do need to divide by 2 since we multiplied by 2. And we have x minus 2 as a factor and 2x minus 1 as a factor. And I'm putting that in thinking bubbles. So the question always comes up, well, how do I write my answer? So we're going to write our answer here as factors and then as roots. Step number 1, we take a look at our GCF. Do I have a GCF as a factor? This GCF would always go under a factor. It would not go under a root. No, I don't have it. Moving up to step 3. Step 3, I did have a root of 1. I'm going to draw an arrow, which means I had a factor of x, opposite of what you see, 1. Then I'm moving down to step number 6. Yes, we could factor. We get x minus 2. Draw an arrow down. That means I have a root of positive 2, opposite of what you see. And then I had a factor of 2x minus 1. Draw an arrow down. Set that equal to 0. Solve, which gives me a factor of positive 1/2. So in this question, it is asking you just to solve. It's not asking you for the factors, but if you do your answers like this, it will be accepted to give both factors and roots. Moving on to B. B is saying state, oh no, it's just saying solve equations as well. All right, so same steps as before. Step number 1, try to factor. What do I see? I see a trinomial. Does it have a GCF? Again, GCF could be a letter, could be numbers. I got a 2, a 3, and a 1. No numerical GCF. X, X, no X. So no GCF on this one either. We're going to try to factor. So I see a leading coefficient that's not 1. That means I need to try to use the rainbow method. With the rainbow method, I'm going to take 2x cubed minus 3x squared plus 1. And I'm already thinking, you know what? This probably won't work. And here's the reason. Yes, I have a trinomial. Yes, the leading coefficient is not 1, but I actually cannot use the rainbow method because it's not a quadratic pattern. The exponent is 3. And because the exponent is 3, I can't use a quadratic pattern trinomial to factor because it's not double the middle term. So the way to check is you're always going to double this exponent, and the leading coefficient exponent here, the leading term exponent, needs to be doubled out. So 2 times 2 is 4. This is not 4. It's not a pattern. No, we cannot factor. So that means, once again, we're going to go ahead and go through the rational root theorem. So we have step number 2. We got our silly snake. We're going to put the constant of 1 over the leading coefficient of 2. Factors of 1 are just 1. Please don't write doubles of this. That means 1 is over 1 and 1 is over 2. So that means our possible roots are plus or minus 1 and plus or minus 1 half. Okay, step number 3, we're going to open up for the x value. And we're going to start typing it into the calculator. So again, I usually start with a -1 because for me it's easier to then go back and delete the negative on that one. Oh, so -1 does not work, so I'm going to delete that negative on 1. Oh, 1 does work, so we're going to input 1, just like that. So that means x is equal to 1. In step 4, we're going to continue with the synthetic division. Be careful here. So this is an example of where, yes, you have a term missing. So I have a 3 as an exponent. I have a 2 as an exponent. I don't have a 1 as an exponent. This one right here where I'm pointing to, that's a constant. So that's this one right here. But we are missing a term right here of 0x to the first power. Okay, take that root of 1, write it on the outside, bring down the 2, multiply on the outside, and add on the inside. Remember, your remainder must be 0. If it does not have a remainder of 0, that means you don't have the correct root, or you made a mistake in your synthetic division. All right, writing it backwards, we have a remainder. We have an exponent of 0, exponent of 1, exponent of 2. Step number 5, we are going to write out our quotient, so the answer to our division problem. You can write a -1 here if you want, or you can just omit it. Okay, and then step number 6, we're going to do round 2. Round 2 is trying to factor once again. And what we're trying to factor is the answer to our synthetic division. I see a trinomial with the leading coefficient not 1, so I'm going to try to use rainbow method again. So that means I have a temporary x squared minus x minus 2. Can I factor this? I believe I can with a -2 and a +1. Again, this right here does not actually exist. This is temporary. Since we multiplied by 2, I have to go back here and divide by 2. So we have factors of x minus 1 and 2x plus 1. Okay, putting that in a thinking bubble because that's not our answer. Let's go ahead and have some space here. Write our answer box. We want our factors. We want our roots. Okay, step number 1, we're going all the way back up here and we're looking for a GCF. That's going to be our first factor. If yes, we have a GCF, we write it here. We don't have any, so we're moving on to step number 3. Step number 3, I did have a root of 1. I'm going to draw an arrow up. That is my first factor of x, opposite of what you see, minus 1. Next, we're moving on to round 2. Round 2, I do have factors. I have a factor of x minus 1. Bring it down, which means I have another root at +1. Then I have a 2x plus 1, which means I have a factor of -1/2. Okay, now I want to point out that this right here is incorrect. So I am going to erase my arrows so I can fix my answer. And I'll do that in a different color so that way you can see. Because I have the same factor twice, that means there is a multiplicity on my root. So in order to write our answer correctly, we're going to say x minus 1 squared, and then have the 2x plus 1. These are our factors, which means for our roots, because we have, I'm going to extend my box here to write underneath. Because we have the same root multiple times, we have to write our multiplicities. So that means the root of 1 has a multiplicity of 2 because it happens twice. And then we have our negative 1/2. Okay, so then what's the answer? The answer to this one, we have our factors here, and then we have our roots here. All right, state all possible. Now this keyword, possible, means do not solve. Okay, so when we're stating all possible roots, let's go back up to question number 1. In question number 1, we are solving. Okay, so I want to show you the difference between question number 1 and question number 2. In question number 1, it is asking you to solve the equation. So we need to get to here to solve. This one is stating what's the possibility of answers, so it's not asking you to solve. So this here is asking you for the possible roots, which are these. Okay, so basically what you're doing step number 2 only. Let's go down here. So for step number 2, you're going to take your constant, your last term, you're going to write it on top of your leading coefficient here. I'm going to highlight it so we can see the difference. And then you're going to write your factors. So plus or minus 1, plus or minus 3, plus or minus 1, plus or minus 3. And again, every single numerator gets a denominator. So 1, I'm going to write twice. 3, I'm going to write twice. And then I'm going to go back and give 1 a denominator of 1 and a denominator of 3. And then give 3 a denominator of 1 and denominator of 3. Okay, simplify this for your fractions. Always write always write a plus or minus. Any repeats we do not need, so we're going to cross out that one. So that means all of our possible roots end up being plus or minus 1. Now you can do this if you want so like write 1 and then 3, but it doesn't really matter. So then what we have is plus or minus 1, plus or minus 3, plus or minus 1/3. Again, order does not matter here. As long as you have all of them, it's fine. Okay, moving on. Once again, this one is saying state all possible roots. So I did give you a lot of space on this because there's going to be a lot of factors. So if we take a look at what we have 24 that's going to be written on top, and then 12 that's going to be written on the bottom. That means I'm going to go in and I'm going to say or ask myself a question. What numbers multiply to 24? Well, 1 times 24, and I'm again giving myself space, is 24. Then I have 2 times 12 is 24. Then I have 3 times 8 is 24. Then I have 4 times 6 is 24. And then in the denominator, I have 1 times 12 is 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. Now again, remember every single numerator gets a denominator of every single numerator gets every single denominator. Okay, so there's going to be needing a lot of space. So I am going to jump down. I'm not going to spend time writing these out. Please check your answer. I am going to write the answer here. Please make sure to show your work. In order to receive credit. The space is provided for you and you have to show your work for credit. Okay, so the answer for this one, for all of your possible roots is we get plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24. Then we get plus or minus 1 half, plus or minus 3 halves, plus or minus 1 third, plus or minus 2 thirds, plus or minus 4 thirds, plus or minus 8 thirds, 1 fourth, 3 fourths, 1 sixth, plus or minus 1 twelfth. So there's many roots, but again, there's going to be so much more that you need to show me. Okay, moving on. Step number 3, find all rational solutions. So rational just means that you're not going to see any square roots or i's in your answers, in your roots. So let's go ahead and do this. The same thing as question number 1A and 1B. Step number 1, we're going to take a look and we're going to try to factor. I see 4 terms. Do I have a GCF? 5 and 11 don't get along. 7 and 1, they don't get along here. So no GCF. I also notice I have an X, no X, so there's no GCF. I'm going to try grouping, but if I do grouping, I already notice that I'm not going to have the same leftovers. So for grouping, I would end up with x squared, 5x minus 11, and 1 times 7x minus 1. So again, these right here are not the same, so therefore we cannot factor. Okay, since they do not match, we're going to continue with step number 2, which is the rational root theorem we just did in question number 2. So we're going to take 1, write it on top of 5. So I get plus or minus 1, plus or minus 1, plus or minus 5, which gives me plus or minus 1 over 1, plus or minus 1 over 5, which means my possible roots are 1 plus or minus and 1/5 plus or minus. Step number 3, I'm going to open up my x value. I'm going to pick up my calculator and I'm going to check which one gives me a 0. Again, I like to start with a, -1 is what I like to start with. So -1 does not give me 0. So I'm going to go back and I'm going to delete that negative. Oh, it does give me 0. Okay, so we do have a root at 1. So for step number 4, write out x equals 1. And the reason we do that before we do our synthetic is just to keep track. Okay, so we're going to use our synthetic division. We got 5, -11, 7, and -1. And what I'm doing here is I'm checking. I have 3, 2, 1, 0, making sure I don't need a placeholder. Take that root, write it on the outside for your synthetic division, multiply on the outside, add on the inside. Get -6 here, -6, 1, 1, 0. Again, this must be 0 in order for us to check that we're doing the correct steps. Next, we're going backwards with a remainder. So remainder, exponent of 0, exponent of 1, exponent of 2. Step number 5, we're going to write out our quotient from our division. So we have 5x squared minus 6x plus 1. Step number 6 is your round number 2. And step number 6 is we're going to try to factor. When you're trying to factor, I'm noticing that we have a trinomial leading coefficient that's not 1. So I'm going to try to factor using the rainbow method. And again, I see that yes, we can factor. We have a -5, and a -1. And again, this right here doesn't exist. This is temporary. Because we multiplied by 5 in this step, we have to divide by 5 here. Simplify. And again, thinking bubble because this is not our answer. Let's go ahead and write our answer. We have factors. We have roots. Starting out with the GCF, here in step number 1, did we have a GCF? No, that would be a first factor. Moving down to step number 3, I had a root of 1. Draw an arrow up. That is your first factor, opposite of what you see. Then moving down to step number 6, yes, we could factor. We get x minus 1. Bring that down. We have another root opposite of what you see at +1. Then here we have our factor, this one, 5x minus 1. Again, set that equal to 0, solve, so you have a +1/5. Okay, now again, this is incorrect. Okay, this is wrong because I see multiplicities. I see multiple things that are the same. So I'm going to erase my arrows. And I see that I have 2 factors that are the same. I need to combine them. And then I can write my 5x minus 1, which means that I do see multiplicities. Here. So for my answers for question 3A, my factors are x minus 1 squared, 5x minus 1, and for my roots, I get 1 with a multiplicity of 2, so 1 mult 2 and 1/5. Okay, moving on to B. And again, this should almost start feeling a little bit repetitive now. The steps are always going to be the same. Step number 1, try to factor. What do I see? I see 4 terms. Do I have a GCF? 2, 1, 2, 1? No. But I did kind of recognize just a pattern when I said that. 2, 1, 2, 1. So I am hopeful. I have an X, 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 no X, so GCF is none. But if I try to group 2x cubed plus x squared and -2x minus 1. Careful here, I am putting that negative inside, okay? This plus is just an English and. It is temporary. It's just us continuing a statement. So I have 2x cubed plus x squared and a -2x minus 1. Let's go ahead and divide out a GCF. Here I'm going to divide out x squared, leaving behind 2x plus 1. Here, I'm going to divide out a -1. Notice how my English and disappeared. I don't need it anymore. And if you notice something pretty cool that's happened for the first time here is, yes, the leftovers do match. That means do not continue to step number 2. What we're going to do is we're going to write out our factors of x squared minus 1, close it, and 2x plus 1, close it. Here, there's an alert. Can you factor more? You have to factor all the way if you actually can factor. So without us going to step number 2 for the rational root theorem, factoring step number 1 did work, but we have to make sure we can factor our factors if needed. So I'm going to go in here. I'm going to take a look at this binomial. This is done. Why is it done? Because it's linear. There is an exponent on x, and that is 1. Now looking at here, I do see a minus. I have an exponent of 2. So this one is yes, I can factor by taking a square root of x squared and a square root of 1. Do not touch that minus. The minus is just a check for a pattern. You don't actually do anything with that minus. So square root of x squared is just x. This is going to be your a value. Square root of 1 is just 1. That's going to be your b value. So the pattern, this is a check for pattern. This is just you making sure that, yes, you can continue. But what you actually need to have memorized is your factoring, which will be x a plus b, which is 1, x minus 1, which is a minus b. So a plus b, a minus b. Bring down your other factor of 2x plus 1 here. And then linear, linear, linear. These are done. These are your factors. All of my factors are different, so I do not need to write any multiplicities. There are no multiplicities here. Next, we're going to go ahead and convert those factors into roots. So I'm going to do opposite of what I see. You can set each factor equal to 0 and solve. So I see a positive 1, I write a negative 1. I see a negative 1, I write a positive 1. Here is where we're going to set this equal to 0 and solve. And I get a negative 1/2 for my roots. Okay, moving on. C is still asking us to find all rational solutions, so we're going to continue the same things that we've done before. I am going to skip C on this one and tell you what my answers are going to be. Remember that you have to show me all work for credit. Okay, be careful here because you will have a GCF. So for my roots, I have a 0, I have a 1, I have a -1, and I have a positive 1/3. So that means for my factors, I'm going to have an x, I'm going to have an x minus 1, I'm going to have a x plus 1, and I'm going to have a 3x minus 1. Again, you must show work for credit. Okay, now here, when they're saying find all solutions means that you could potentially see radicals and i's in your answer, in your roots. Okay, so be careful on that one. Step number 1, let's go ahead and try to factor. What do I see? 1, 2, 3. So I see a trinomial. Let's check for GCF. X, X, no X. So I don't have a GCF. I see a leading coefficient of 1, so I'm going to try guess and check. Two numbers that multiply to 56 but add up to a negative 1. So 56 divided by 8 is 7. So we can do this. So -8, +7. So the trick with higher powers, and the reason we can do it this time instead of last time we couldn't do it, is because we have x squared. And x squared, this 2, this exponent of 2, 2 times 2 is 4. So that means, yes, we have a pattern that we can use for factoring. Okay, next up, we're going to go ahead and check if I can factor more. This is very important when, yes, you can factor. Can I factor more? Notice here that I have not a linear. This is an exponent of 2. This one here is an exponent of 2. So here I have a minus, I have a squared, and I have an 8. So this one is unfactorable. And the reason is this is a quadratic binomial, so meaning there's an exponent of 2. So cannot take the square root of 8. So this one's done. Here, again, we have an exponent of 2, so it is quadratic binomial. So we see a minus, first of all, which means we're done. And then we cannot take the square root of 7. So as we are writing our answer, let's go ahead and create our box. We're done factoring. Our factors are x squared minus 8 and x squared plus 7. I cannot factor more. But what are my roots? What are my x equals numbers? So in order to solve, what you're going to do is you're going to set each bubble equal to 0. Now that you have it equal to 0, we're going to add 8 to both sides. This is going back to your integrated math 2 lessons. And we're going to solve by taking a square root of both sides. Now, when you take the square root, this is very important. You must include a plus or minus because you're going to end up with 2 roots instead of 1. Here we have x is equal to plus or minus the square root of 8, which I am going to cross out. This is wrong because you need to simplify your radicals. Again, that's an IM2 skill. So we have plus or minus, we're going to break apart 8 into 4 times 2 because 4 times 2 is 8. But the reason I'm choosing to use 4 is because I can take the square root of 4, which is 2, and then have my root 2 left over. So going into our answer box, for my factor of x squared minus 8, my roots are plus and minus 2 root 2. Okay, let's do the same thing for the other one. I'm going to subtract 7, x squared, negative 7. Take the square root, take the square root. Make sure you take that negative on the inside here. So that means I have x is equal to plus minus the square root of negative 7, which again, that is wrong. So I am going to cross that out. Now, square root of 7 cannot be simplified, but I do have a negative inside that I need to remove. So I'm going to remove that negative 1. And square root of 7 cannot be simplified, so we're going to keep that. Which means I have roots I, so the square root of negative 1 is I, times the square root of 7. So here in my answer box, I'm going to write in my other 2 roots of plus minus I square root of 7. So if we take a look at the highest exponent here, total degree, highest exponent is 4. I should have 1, 2, 3, 4 roots. Okay, moving on. B. Here we have x cubed plus 1. Be careful here. So let's go ahead and factor. So I'm trying to find my pencil here. Here it is. Step number 1, try to factor. I see a binomial. Again, first check is if it's a quadratic pattern with a minus. So it's not quadratic, it's not a minus. But can I take a cube root of my values? And the answer is yes. So I can take a cube root here, and I can take a cube root here. So that means my A value is just x. My B value is just 1. So this is a cubic pattern. Again, this right here is just checking if something exists. Now we need to actually write out what it is that exists. So our pattern is, I'm going to write the pattern, then I'll fill that in. A, B, a squared, a times b, and then b squared. Now for our symbols are always same, always different, and then always positive. So to put in our a's and b value, we have x plus 1, x squared, be careful here with the parentheses, x times 1, and 1 squared. Simplify, x plus 1, x squared minus x plus 1. And again, we're going to check if you can factor more. When step number 1 does work, you want to make sure that you factor completely. Can I factor more? This one here is linear. We can see the exponent of 1 on x. This is done. And then this one here is also done. And the reason this one's done is a trinomial from a cubic pattern. Your trinomials from cubic patterns will not factor. And then I'll show you in a few seconds why. So let's go ahead and write out our answer boxes. So we got our factors of x plus 1, x squared minus x plus 1. And so here are our roots. So the linear roots we can do really quickly. Opposite of what we see here, we get -1 as a root. But for solving the trinomial, we're going to set it equal to 0. We're going to identify A, B, and C. Be careful here with the negative. It is a -1. Oops, no plus. And we're going to be needing to use our quadratic formula again from Integrated Math 2. So quadratic formula, I'll write it here in a thinking bubble. -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so what that looks for us is -b, be careful here with the double negative, plus or minus the square root of b, again, careful with the negative, squared minus 4ac all over 2a. As you're solving, you must first solve on the inside of your radical. So you're going to be typing in just this section into the calculator. Do not type in the square root. And the reason being, sometimes when you have things like negatives and i's, your calculator is going to give you an error when an arrow doesn't technically exist, because we can do it by hand. So I'm just typing this in. Okay, here it is. So then what we have, go ahead and simplify when you can, like double negatives. So we have 1 plus minus the square root. Now what I have inside is -3. 2 times 1 is 2, which again, if I was to do a square root of -3, it would give me an error. But this error is not true because I can remove that negative and then continue simplifying. So I'm just pulling out that -1 like we did before. Square root of -1 is I. So we get 1 plus or minus I root 3 over 2. If you can simplify, you must simplify, which means here we're going to check by splitting this answer into 2 fractions. And again, outside with outside, inside with inside. So what I'm looking for to simplify is I'm looking if these two are going to simplify and if these two are going to simplify. If yes, we can, go ahead and simplify. If you cannot, just keep it original. So I'm going to write cannot simplify. So we're going to go back up to our roots. And we have a root of 1 plus minus I square root of 3 all over 2. Okay. Step number 3, or question number 3, again, is going to be similar to that. Go ahead, and I am going to skip this question. You must show work for credit, and then I will provide you the answers of that. So must show work for credit. And then the answer for that one is going to be, let's go ahead and write this out, factors and roots. Do I want to write the factors for you? Sure, why not? So we have our factors of x minus 5, x squared plus 5x plus 25. And then our roots are going to be a positive 5. And then we're going to have plus minus negative 5 plus minus 5I root 3 all over 2. Okay, so our exponent is 3 here. So I should have 3 roots. 1, 2, 3, because plus and then minus. Okay, moving on. D. Okay, I'm going to do the same thing for D. I am going to write out the answer for you. Make sure that you show work for credit. And let's write out our roots and then our factors. We have plus or minus 3i, plus or minus I, root 5. So we should have 4 of them. And then we have our factors of x squared plus 9, and then x squared plus 5. Okay. Moving on to question number 5. Actually, that went kind of fast. Okay, make sure you have this and you must show work for credit. Question number 5, write the equations in standard form, which is the expanded polynomial form. So my hint for you is that you should not have any bubbles, square roots, or i's in your answers. If you do, that means you've done it wrong. Okay. So for question number 5, the given roots, we're going to create a mini table here. So here are root section. Here's the factored section. And then here's the multiplicity. So for example, we have 3 as a root. That means I am going to have my factor as x minus, here's 3 that's going to go in here. And my multiplicity is 2. Next, I have a root of 2i. And this one comes with an alert. And this must have a conjugate. If you don't have a conjugate, it's wrong. Okay, you're missing half of it. You're missing 50% of it. So because this is a positive, I do have a negative 2i as my root. So we would continue here as x minus, open and open. Put in the 2i, put in the negative 2i. And because they're not telling us any multiplicities, that means I have a multiplicity of 1 for both. So let's go ahead and write this out in factored form. Now, when you're writing, it is an equation. This is very important. We're not writing this as an expression. So everything that we've done before, we're just listing out a list of factors. But here, they're actually wanting equations. So for an equation, we need to include either an f of x, a p of x, something of x. Usually we go p of x because it's polynomial form. And we're going to be writing out our factors. So I get x minus 3 multiplicity of 2. Then I have x minus 2i. And what I'm doing here with arrows is I'm distributing that negative. Sometimes you have multiple things to distribute. So you could end up with a trinomial here. This right here is not my answer. This is in factored form. If they wanted it in factored form with the parentheses, you'd be done. But what they want is they want you to expand. So my first expansion is going to be expanding my x minus 3 into x minus 3 and x minus 3. I'm writing it twice. I still have my x minus 2i, x plus 2i. And when you're going to be expanding, you're going to be multiplying. You have to multiply the conjugates together. After you multiply the conjugates, it doesn't really matter what order you multiply in, but conjugates must be multiplied together. But since I have x minus 3 twice, I will multiply these together as well. Once you get your answers for these two multiplications, you're then going to multiply those answers together. I encourage you to use a box method to organize your thoughts. You do not have to use a box method. I just encourage it, especially if you have like trinomials. Remember, you're adding the exponents together, so 1 plus 1 is 2. Here, it doesn't matter where you put the x. I do encourage that if you put the x in the back, then you just keep that order. Otherwise, you will sometimes mess things up. So you got negative 2, positive 2, so negative 4. I times I is I squared. Here again, remember that I squared is actually equal to a negative 1. So what you have in this box and why we need to multiply conjugates together is we need to remove anything like square roots and i's. So what we have is negative 4 times a negative 1, which gives me a positive 4. Notice that we will remove a positive 2ix and a negative 2ix. Those are gone. So after I multiplied my conjugates together, what I ended up having is x squared plus 4. Let's go and multiply the other one. So I get x minus 3, x minus 3. I get x squared, negative 3x, negative 3x, and positive 9. Here, again, nothing to do with I. This is just regular binomial multiplication. So what we have here, we're going to add these together. And I'm ending up with a trinomial of x squared minus 6x plus 9. Now I need to multiply these together. Again, I encourage you to do a box method. And the reason box method I like is just because it helps you organize your thoughts. So we got x squared minus 6x plus 9 and a binomial of x squared plus 4. Remember, you're adding your exponents together. So 2 plus 2 is 4. 2 plus 1 is 3. 4 times 6 with a negative is negative 24x, and then positive 36. So after that, add things if we can. So I only see some things that we can add. I have an x squared, x squared. Everything else is different. So I'm looking at x to the 4th minus 6x cubed, 9, 10, 11, 12, 13, x squared minus 24x plus 36. And again, because they are wanting it in polynomial form as an equation, you have to include the equals p of x. If you don't, that will be points removed. It doesn't have to be p, it could be f of x, g of x, h of x, but it does need to be an equation. Alrighty, on the next question, this is asking us to write our given roots. So this one, if you notice, I do see a square root here. Anytime you have a square root or an I, which we do have here, that means conjugates are part of our roots. It comes in a pair. Now, most of the time, they do not tell you that you have a pair. They only give you one of the roots. And then, sorry, that's my kitty cat. And then they tell you that you need to acquire these roots on your own. So we're going to create a table. I did give you lots of space. You're going to write out your roots. You're going to write out your factors. And then you're going to write out your multiplicities. Now, unless they tell you you have a multiplicity, your multiplicity is 1, meaning you don't have a multiplicity. So our first root is 3 plus the square root of 5, which means that a conjugate exists. We're going to take that plus, make it into a minus. Our a and b values are still the same. So root 3, square root of 5. And then we have the other term of 1 plus 2i, which again, because we have that I, I'm going to take that plus, I'm going to make it into a minus. And then we have the conjugate. Again, A is the same, B is opposite of what we see. When we write out our factors, you're going to write this as x minus, open your parentheses for each one. Inside, we're going to write in our roots of 3 plus square root of 5, 3 minus square root of 5, 1 plus 2i, 1 minus 2i. And again, since they did not tell us there is a multiplicity, all of our exponents are going to be 1. So in factored form, they're asking for a function. So f of x is equal to, distribute this minus onto 3 and negative 5, onto positive 5 and negative, onto 1 and positive 2i, and onto 1 and a negative 2i. So our first factor is going to be x minus 3 minus square root of 5. And I don't think I'm going to have enough space. Then we have x minus 3 plus square root of 5. Yeah, definitely not enough space. Then we have x minus 1 minus 2i. Then we have x minus 1 plus 2i. Now this here is in factored form. If they are asking you, go ahead and write this in factored form. This is it. You are done. If, however, they are asking you to expand, which I think they are, yeah, it's asking you to write it in expanded polynomial form. That means we need to multiply this out. When you're multiplying this out, you have to multiply the conjugates together. Otherwise, things are going to end up really messy. Multiplying conjugates together gives us elimination of things like square roots and things like i's. I'm just rewriting this so I can show you. Oops. Oh, it's okay. I'll write plus I and then I'll write the minus I. So conjugates need to be multiplied together. So these two factors are from conjugate roots. And then these two factors are from conjugate roots. So with our box method, we have a trinomial times a trinomial. We have an x minus 3 negative root 5. We have an x minus 3 positive root 5. Here we have Again, trinomial times trinomial. And the reason I'm choosing to use box method is to organize my thoughts. X minus 1 plus 2i, x minus 1 minus 2i. We're going to go ahead and multiply these. Remember, adding exponents here. So we got x squared, negative 3x, negative x, root 5. Do not put that x on the inside. It is outside. We cannot go inside a radical. Negative 3x, negative negative is a positive 9, positive 3 root 5. Here we have a positive x root 5. Here we have a negative 3 root 5. Here's where you're going to notice in this very last box where your square root is going to eliminate. So I have a negative times a positive, which gives me a negative. I have inside a root, I have 5 and 5, which gives me 5 times 5, which is 25. Here we can take the square root of 25, which is just 5, and we don't have that. Now, when we focus on conjugates, you'll notice that things are also going to eliminate. That's the whole point. And the whole point is to eliminate our square root. So we have a plus version and a minus version here. We also have a plus version and a minus version here. And what that will do is that will eliminate, remove these terms. And we can continue to combine like terms here, adding these negative 3x's. And then these ones here, we do need to add subtract. So this multiplication gives us a polynomial of x squared, or a trinomial, a x squared minus 6x, 9 minus 5 is a positive 4. I'm going to put that in a thinking bubble. This is not my answer. I'm going to go move on to the next multiplication. We got x squared, negative 1x, positive 2ix, negative 1x, positive 1, negative 2i, negative 2ix, negative negative positive 2i. And again, here in this very last box, that's where you're going to eliminate your i's and your square roots. So here we have an I. Negative times a positive is a negative. 2 times 2 is 4. I times I is I squared. And this I squared is special because we will be removing I squared. And I squared is just negative 1. So we have negative 4 times negative 1, which means I have a positive 4 in this location. Adding, subtracting, and eliminating. We're going to be adding these together. We're going to be adding these together. For our elimination, I have a positive 2ix, negative 2ix. That's gone. Next, I have a negative 2i and a positive 2i. That's gone. And that's supposed to happen. If it doesn't happen and you are left over with an I or you are left over with a square root, that's wrong. Let's go ahead and write this out. X squared, 1 and 1, that gives me 2. 4 and 1 gives me 5. Now this is not done. We are asking to expand all the way, so that means these are going to be multiplied. One last time with a box method for us. We got x squared minus 6x plus 4. Here we got x squared minus 2x plus 5. Again, adding these exponents, 2 plus 2 is 4. 2 plus 1 is 3. And we got x squared here. Adding the exponents, negative 2x cubed. Negative negative is a positive. 6 times 2 is 12. 1 plus 1 is 2. Negative 8x. 5 positive x squared. Positive negative is a negative. 6 times 5 is 30x. In here we have positive positive, which gives me a positive. 5 times 4 is 20. Notice that we should not have any square roots. We should not have any i's here, but we are going to be combining these terms that are alike. So I need to add these together. I need to add all of my x squares together. And we are adding these together. And I need to add all of my x's together. So overall, in the end, we do end up with a polynomial. P of x is equal to, you can call it P of x, F of x, it doesn't matter. We got an x to the fourth power, negative 8x cubed, 21. Is that 21? We get a positive. Oh, did I make a mistake? Let's see if I made a mistake. Nope, that's good. I was just checking my values. So we have, I'm second guessing myself. Hold on a second. We got 12 plus 5 plus 4. It's been a long day. 21. And we're left with negative 38 x plus, oh, I'm barely going to make it. I'm going to have to rewrite that. So let's try this again. X to the fourth minus 8x. We said this was 21x squared minus 38x plus 20. All right, this is your expanded form. All right, moving on to the next one. Writing the equation for the following polynomials in factored form. Factored form means you are going to see bubbles. That means do not expand. The issue with these type of questions is that I am asking you for an equation. So we must give you either P of x or F of x as part of our answer. If you don't give me an equal sign, that means it's not an equation, it is an expression, and that will be points removed. All right, when you're starting to work on these here, you're going to identify your roots, which are your x-intercepts, which are on the x-axis. So I have a point here, 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 and I have a point here. Now, order technically doesn't matter, so it's easiest just to start from the left to the right and see what your x values are. So I have an x equals negative 8. I have an x equals negative 6. I have an x equals negative 4. I have an x equals 0. And I have an x equals 4. These are your roots, your x-intercepts. From here, we're going to write out our factors, which is the opposite of what we see. So our factors are x plus 8, x plus 6, x plus 4, x plus 0, and x minus 4. And we'll talk about that 0 in a little bit. Next, we're talking about the behavior. We have 3 behaviors to work with. We have an odd, even, or linear. We're looking if it's a straight line, it is linear. If it's a straight line, it is linear. If it's an even, it's going to look like a parabola. And again, this is going to be of least degree. And if it's a line, it's linear. And if it looks like there's a bend, that's an odd. Now, let's talk about this 0. This 0, if I have x plus 0, that's just x. We do need to simplify this factor here to just x. And now this is where I say order doesn't matter, but you do want to bring out this factor of x in the front. Otherwise, it just looks weird. Now, the rest of them, that part doesn't matter. Now, question comes up is, well, do I need to write my exponent of 1? No, not really. If the exponent is not there, I am going to assume that you are saying that the exponent is 1, not that you didn't look. Now, if you didn't look and it ends up being what it is, be careful. So I would say write it if you want to be very clear about your answer, but if you also want to eliminate the 1 and just leave it, that's fine. All right, next we want to solve for our a value. So let's set this. I'm going to do, I don't know, let's do p of x, very tiny here. We want our a value. Now for questions like this, you're going to assume a is 1 or a is negative 1. We got to look at which one we have. And that's going to go at your end behavior. If we have a as 1, that means we have an increasing function. If a is -1, we have a decreasing function. And since we are going down to -infinity and down to -infinity, that means we have an even function that is decreasing. So that means a needs to be -1. So for our actual answer, let's use p of x is equal to -1 x times x plus 8, x plus 6, x plus 4 squared, and x minus 4 cubed. Okay, put that in a box. Let's do the other one. And let's try this again. Again, what x values do we see? Now, I kind of gave you here. We have an x equals -1. I do have an x equals 0. I do have an x equals 2 and an x equals 4. That means we have our factors of x plus 1, of x plus 0, of x minus 2, and of x plus 4. Next, we want to, if we have it, this doesn't always happen, but if we have a 0, we do want to simplify that. Let's look at our behaviors before we do that. At -1, I do see a line, so it's 1. But at 0, I see an even behavior because it is a parabola. I also see here an even behavior and here an even behavior. So when we take our x and bring it forward, we got to take that 2 here as well. So my factor is just x, but my behavior is still even. So we're going to bring that out and write it as x squared. And then after that, we still have our behaviors, our factors of x plus 1, x minus 2 squared, and x plus 4 squared. We do want to set this equal to f of x, p of x, let's call it f of x, and we still need to determine our a value. You're going to ask yourself a question, is this an increasing or decreasing function? Increasing means a is a positive 1. Decreasing means a is a negative 1. So if we're taking a look here, we have going down, going up. We are increasing. And we are going up from left to right. So we have an increasing function. So to write our final answer, we calling this f of x is equal to a positive 1, open, x. You can do x squared like this. X plus 1, x minus 2 squared, and x plus 4. And I am going to write this out one more time. Just for space, f of x is equal to 1, x squared, x plus 1, x minus 2 squared, and x plus 4. Now the question is going to come up is, do I write this 1 on the exam? Yes, please write this 1 on the exam. Otherwise, I won't know if you did it or you didn't look, and I can't grade something I cannot see. So yes, on the exam, be extra with identifying that you have an increasing function. If you want to state that a is 1 and then not put it in your equation, make sure that you put a box around increasing a is 1 so that way I know you're not just skipping a step. Okay, moving on, write the equation for the following in this function. So this is a cubic function in a different format. Y equals a times x minus cube plus k. You're going to start by identifying your point of inflection. And your point of inflection is going to be that bend. Wherever you see that bend happen, that's your point of inflection. So our point of inflection is going to be at -2 and -2. That is going to be your h and k values. Remember, h is always opposite of what you see. K is for keep. So when we are writing this out, we have y equals a, open x. Now we're going to do opposite of what we see, and then k is for keep. So our h is now positive 2 like this, and our k is still negative 2, so minus 2. Next, you're going to select a point on the curve. So I am going to select this one here. It doesn't matter which one you are choosing. These are going to be your x and y values. Do not do anything about opposite with your x and y value. Y is 1. X is negative 1. And now your task is to solve for A. We need to solve for A. On previous exams, I did see some issues here with order of operations, so be careful. The first thing you're going to do is you're going to remove your K value. Start here by removing this first. That way you're less likely to make a mistake on the following steps. I'm going to add 2 to both sides, which means I have 3a open negative 1 plus 2 cube it. Here I'm going to add subtract, so I have positive 1 cubed. Then I'm going to actually cube my value. Now I am taking a little extra steps with like a 1, but I just want to show you sometimes this is not a 1, so you want to be careful. Next, we're going to be dividing by this number, so I'm going to be dividing by 1. A is then equal to positive 3. I'm going to put this in a thinking bubble. This is not your answer. So for your actual answer, we are going to be changing out 3 things, 2 things, no, 3 things. Here's our format. Y equals A times X minus H cubed plus K. There's 3 things that we need to change. We need to change our A value, our H value, and our K value. The X and the Y, they stay the same. So Y is equal to A was 3, X opposite of what you see plus 2 cubed plus, just kidding, it's a minus 2. And we have our answer. Make sure you have a cubic. Sometimes you do everything correct and then you forget this 3. Don't forget this 3. You have to have an exponent of 3. Otherwise, your function is going to be incorrect. Okay. Moving on here, this one's going to be exactly the same. I am going to provide answers for you. You have to provide work. No work, no credit. And let's write out our answer. In our answer box, we get y equals 3/4 x minus 2 cubed plus 4. If you want y, that's fine. If you want to keep it as f of x, since that's what they gave you in this format, that's okay as well. I'm not very picky about that. As long as you are giving me an equation, it's okay to say f of x or y. Question number 8, we are moving on to describing the transformations. This is going back into chapter 2 information and then moving it into a chapter 3 review. So yes, these questions 100% will be part of your chapter 3 exam. Do not think that this is from chapter 2 because yes, it is part of chapter 3. So what we're doing is we're going to identify every single change from our parent function, which is x to the 5th power. So if it's not x, and if it's not to the 5th power, that means we need to tell what happened. So because we see a negative out in front, we have a reflection across the x-axis. This 2/3 is smaller than 1. That means we have a vertical compression by 2/3. Now this is inside. This is adding, subtracting. That means h is opposite of what we see. So I have, let's do I see and then I see a positive 3. That means I have a negative 3. That means I go left 3. Now, I am going to cross this out because this right here is not part of your answer. Sometimes I see them as your answer. That's not your answer. This right here is your descriptor. And then for your -4 on the outside, this is just down 4. Okay, number 9. Number 9 is asking you to determine if this is an odd, even, or neither. Now, this right here on the exam is a tricky question because sometimes I see just answers. It's not a guess the correct answer situation. It's show your work, otherwise you get 0 points situation. So if you do not show work on the exam, expect to get 0. Not 1, not 2, not partial credit, not you guessed the correct answer. It's absolutely nothing if you show me nothing. Step number 1, you're going to open up your function. 3, open. 5 minus 4, open. You're going to insert a -1x. Now, yes, I actually do want you to write this as -1x because then you can use a calculator. Next, you're going to evaluate what we have. 3, open to the 5th power, minus. And then here, I'm going to type in -1 in parentheses, caret 5. This is going to tell me if it's going to change to a negative or it's not going to change to a negative. Here, I am still keeping a negative. Now this, I need to type in as -4, open -1, and that actually changes to a +4. The x's stay, don't change your x's. But this has been simplified. Now that we're here, we got to simplify a little bit more. -3 times. You know what? I'm going to change that real quick. I'm going to change that. Let me erase that because I feel like I can make it make sense a little bit more, especially coming into, or I guess coming from our expansions of binomials. When we were expanding binomials, here's my 3. I did ask you to write it a little bit different way. And I asked you to open up for your -1, and I asked you to open up for x. And I feel like this will make it a little bit better because why are we comparing something or connecting something when you can't? So this is why we end up saying, okay, well, what is -1 to the 5th power? Well, that's just -1. Then we still have our x to the 5th power. And then here, again, you could have separated -1 times x. So now we have -3 x to the 5th power plus 4x. And this is what I'm going to be comparing to the original. If it is the same as original, it is even. If it is not the same as original, then we're going to try to factor. So right now it's not the same. So that means it's not even. Now I'm going to try to factor out a -1, and that's just dividing by -1 here and here. Pulling that -1 out, I get 3x to the 5th power minus 4x. And what I'm looking for is on the inside, so the leftovers here, do they match the original? Yes. So these leftovers match, but only after factoring out a -1. That means it is an odd function, and that is your answer. You're going to do the same thing here. I am going to write the answer. You must show work for credit. The answer for this one is that it is even. But again, no work, no credit on the test on your homework. And for C, once again, it is being asked odd, even, or neither. I am going to give you the answer. This is going to be a neither, neither, neither. And again, must show work for credit. Moving on to question number 10. Question number 10 is asking you to write your transformations. And it is something that we did again in chapter 2. We are continuing it in chapter 3. And yes, this will be on the test. You're going to start out by writing your original. Then you're going to reflect across the x-axis. Translated 3 units left. And shifted 5 units down. Before you do anything, you're going to go in and you're going to write the function notation for each. So a reflection across the x-axis means you have a negative in front of your function. A left 3, left means minus. That means you see a negative 3. That means what you have inside of your function is a positive 3. Down 5 means outside of your function you have a minus 5. Okay, let's start with the original. It is up to you if you want to use y or if you just want to ignore that. I'm going to choose to ignore that for space. That means this function right here, what I just drew a box on or around, this function is now going to be opened up inside parentheses. I'm going to be writing 3 open x minus 4 cubed plus 8. Now I do have that minus on the outside of the function, so here's my minus on the outside of the function. Now because this is an outside change, I am unable to go inside of my cubed. So these parentheses here showed in yellow, these are my inside, and I only can apply that negative on the outside of the function since it is an outside change. So simplify this, I have negative 3, open x minus 4 stays, and then I have a negative 8. So again, these right here are inside versus I have my outside of negative 3 and negative 8 now. Next, we are taking this transformed function, bring it up, and now I have an inside change. Now this inside change means I'm going to open up 4x. Here's my x value right here, and I'm going to take that x plus 3, and I'm going to put this x plus 3 inside. Inside with inside, outside with outside. So I still have my negative 3 and my negative 8, but since I am working with the inside now, I can simplify the inside. And I actually have to simplify the inside. So I still have negative 3 on the outside and negative 8 on the outside. Inside now, I have x plus 3 minus 4, which is going to give me x minus 1. Okay, put that in a thinking bubble. And now we're going back here. Again, I have my function. That's my function. And behind that function, I have a negative 5. So since my translation is happening outside of my function notation, that means I'm going to be writing negative 3, open, x minus 1, close it, cube it, minus 8. And again, outside with outside, this is not distributing. This is combining like terms. So that means I am going to combine the outside negative 8 with an outside negative 5. We get negative 3, open x minus 1, close it, cube it. Negative 8 minus 5 is a negative 13. Yes, we need function notation. You can call it fx, g of x. What do they want it? They didn't state. So it doesn't matter if you give me a g of x, f of x, p of x, q of x, r of x, something of x. Let's do this one. Again, similar steps. Let's start with our original. Then we have reflected across the y-axis, horizontally compressed by 1/3, and shifted to units right. Writing out our original, you have a choice. Keep the y, don't keep the y. That part doesn't matter. Don't forget that 2 is included in your function. All right, let's go ahead and write out our function notations before we begin. The reflection across the y is an inside change. Horizontal compression is an inside change. Be careful here because it is a reflection and a reciprocal, not a reflection, excuse me, a reciprocal. So inside, we're going to be writing 3x. And then right 2 still is inside. Again, right means positive, so opposite of what you see, -2. All right, let's go ahead and begin. Since we are starting with an inside change, I'm going to take my function, negative, open, 1/2. I'm going to open up for x. Keep track of that 2. That 2 seems like it's going to be something that's easily missed. And I'm going to put in my negative x here. Make sure to simplify since it is all inside. So we get -1/2 here, x minus 6, close it, cube it, -2, thinking bubble, moving on to our next change. Again, inside, so once again, I am opening up for x, and inside putting in 3x. How you simplify this, it really is kind of up to you because I can make this into a denominator of 1 and then proceed to that. This is multiplication, so be careful with that. You don't need to do like common denominators. You can multiply 1 and 3 and then leave the x, but I'm going to go ahead and multiply 1 and 3x, which gives me 3x over 2. If you want to put x next to it instead of on top, that's fine as well. Here's my function moving up. And then again here, we're going to open up our function. So negative open, -3. We're going to open up x. And we're going to divide by 2. -6, cube it, -2. And again, we're going to put in this x minus 2. Go ahead and distribute that. We do need to simplify on the inside. We get negative open, -3x plus 6 all over 2 -6, close it, cube it, -2. It's not the prettiest thing that we've seen, but it is what we have. Call it p of x, f of x, q of x, doesn't matter. Put a box around it. All right, moving on. There are 2 more questions. I think that's it. Yep, there are 2 more questions on here. I am going to leave these 2 for you to try on your own. You must show work for credit, and then I am going to give you answers for this. So that way you can check your work and make sure you've done the correct job. So for question number 12, the answer is -1/2, 2x plus 10 cubed minus 6. I called it g of x. And then for question number 13, 3 open, -2x minus 5, close it, cube it, -7. Hold on, -10. Let's see. My kitty cat is playful. Let's see if you guys can see her. There she is. Yep, it's the pencil. It's always the pencil. Yep, she's trying to bite it. All right, sweet girl. There she is. All right, anyways. Come here. We are here, and this should be a negative 10 equals g of x. Again, as always, must show work for credit. And again, here, must show work. Alrighty, that is it, beautiful people. We're going to say goodbye, and we'll see you in the next one.